core contributors here from the NANDA team. So I'd like to ask Sichao, John, and Rob to join me on stage over here for a quick panel session on the NANDA index and what it means. Thank you, everyone. All right. So we have three amazing senior engineers from pioneering companies in the web, PC, internet interface. So first of all, I'd like to ask John, Rob, and Sichao to quickly introduce yourselves.
Hello, hello. I'm John Zinky. I'm from Akamai. I used to work on the ARPANET as part of Bolt, Beranek, and Newman, and so I'm an expert in how to deploy systems, and we're going to figure out how to deploy AI systems in this decade as opposed to the last three, which we did objects and web pages and telnet.
Rob Lincourt. I'm a distinguished engineer at Dell Technologies, and I work in kind of the infrastructure for the consumer all the way through, a lot of large enterprises.
Sichao Wang. I'm a product leader in Cisco systems, and I've been working on cybersecurity maybe for the last few decades, and fraud, identity, and cyber attacks. Most recently, I've been leading product team focus on firewall as a service, IPS, and also DNS security. I think this topic is going to be very relevant to what I've been working on.
Awesome. First of all, thank you so much to all three of you for being here and sharing your knowledge and insight. I'd like to start with talking about the NANDA index itself. So, Rob, if I can ask you, so the NANDA index by design is this lean sort of index that stores very static information, almost like a phone book. So is it just a phone book or is it beyond a phone book? And why do you think the NANDA index is so important for enabling the agentic web?
So I think it's more than just the phone book, where you can almost relate the index to what Google has in their search index, right? Where it's a set of information. It enables you to find something to then start that next step, that next set of interactions. It's like a phone book in that that's what it used to do, right? It enabled you to start that next set of interactions. One of the reasons why I think it's important is we need one way. And again, I'm going to put my enterprise hat on, right? Because that's where I've been for most of my career. Is the enterprise loves how the internet works today, because I search my intranet, then I go to the internet when I can't find things. Whether if I'm resolving DNS, I have the controls in DNS to have that ability to change that search path of what DNS servers get found at what time. And then I can control my security controls. I can now see who can see what and when, and what sites are allowed and what sites are not allowed. And all of that flexibility has to be in that next layer, because our agents are going to have to do that. Both for you all coming into the enterprise and interacting with them, and as well as the enterprise going out and finding those other ones. So it has to have that bi-directional thing, which we don't have today. So that's one of the things that I hope we can solve with this.
Great. So basically, like this essential lean layer for interoperability beyond silos and enabling that interaction. Perfect. John, so just following up from that, so one of the critical pieces of this NANDA index architecture is this agent fact schema, right? And the agent fact schema is it's unique because it's not just self-described capabilities and aspects, but it's certified, audited, detailed, and dynamic metadata. Why do you think this is a critical piece for the agentic web?
Yeah, the agent facts give you what might have been called the yellow pages back when there were phones. And the idea is that you have a lot of metadata, but you have two kinds, well, you have like a bunch of different kinds, but basically there's what the agent can do, which is a what, and then how you want the agent to behave. And so the discovery part really is about am I going to find some agent that's going to actually do what I want it to do? And then there's the resolution part, which says, how am I going to get the interaction between these agents? And this is a lot different than the old client-server model, where the requester was the initiator of what's going on. Here, agents they have agency, so they want to talk amongst each other. So there's a lot of peer-to-peer interaction. And once you figure out who you want to talk to, you might have a session between them. So all of those things are a lot different. Those interactions are a lot different than the traditional client-server model, which is what the current internet is set up to handle. So we're going to have a lot of fun work ahead of us in the next decade.
Yeah. Yeah, please.
One quick thing to that, and I'm really going to show my age now, because growing up, we actually had 2 phone books because we lived that close to a bordering state, right? We were within the 1.5 miles, and they had to send us 2. We had to get one for the other zip code that was across, basically, literally across the street, versus the one that was on our side of the street. So the geo capability of this is going to be important as well, because if you're asking someone to do something for you in a specific geo, whether it's the geo you're in or a geo that you might be sending someone something, you have to understand that concept too. So the location of the physical is also going to be very important, and that's something we've talked about briefly, but we haven't talked a lot about.
Absolutely. And Sichao, did you want to add something to this?
Yeah, absolutely. So I think the first thing fundamentally we need to keep in mind the difference of traditional client-server model for internet access versus today's agentic access. And think about AI agents as a virtual human being. They're not static, like an IP address representing a browser, the source machine. And they have, behaviors, they have capability, they have skills. They can initiate a conversation, they can initiate a task operation. In that sense, it demands the NANDA platform to address that security and trust issues. Versus DNS resolution, you got IP of the client machine, then you can establish TCP/IP communications. There's insufficient, maybe unnecessary check-ins on IP addresses. That's actually create a lot of security issues over the last many years. DNS reflection, DNS amplification, DDoS attack against the DNS infrastructure, and also victimize the consumers, the users, and tricking them to a website have phishing JavaScript, or stealing their personal data. So the security community is have been overwhelmed with the issues on the DNS mechanism we have in the past. And definitely NANDA is well positioned because NANDA architecture does enforce agent fact checkings, and also have cryptographically signed signatures, make sure that we know the source requester is who they claim to be, and we know the capacity, the capability and skills of the target agent you're associated with. We're going to building a layer of filtering, allow you to be only associating with the target AI agent that are relevant to your business. So you'll not be talking to randomly, AI agents on the internet and expose yourself to the, attacks. I think this is a great, exciting architecture we have today, and that's one thing I'm gonna add on.
I think the analogy you made of thinking of agents as virtual human beings, I think all of us kind of make that connection, but it's such a rich analogy because agents have skill, but agents also need to be audited. They also need to be certified. Someone needs to keep them in check. They need a reputation mechanism. all of the things are a lot more nuanced and complicated than they were with web pages, just because of agency, intelligence, and dynamic behavior. And so, such a so we really need detailed schemas. But with agents, the problem is we need detailed schemas, but we also expect such a massive scale that we need this type of two-layered architecture so that we can support the scale, basically, right?
Yeah. So just to give some concrete examples, let's say you have a K-12 educational AI agent, your kids at home, using AI agent to find questions or, exercise for themselves. You don't want this AI agent to be associated with any random AI agent on the internet. They may have malicious intent. So making sure that the AI agent itself, like a human being, when you search on internet, you're able to enforce a safe search and filtering down those high-risk AI agents, filter down those unrelevant AI agents, only expose the potentially verified, keep meeting your expectation, and so that AI agent can interact and collaborate, and then finally settle down the right target AI agent to work with. So this is a very important, perspective we need to consider. Yeah.
Yeah, that's a very good point. John, you mentioned that you were part of the ARPANET project. So you literally have a non-zero contribution to why I can watch YouTube videos today. So, uh, especially during the pandemic, I don't know what we would have done without that. So, what are the sort of learnings from back then? And Rob and Sichao, I'd love for you to chime in as well. But what are the learnings from back then? I know you touched upon the fact that it took us 3 decades to come up with a reasonable, 4 decades to come up with a reasonable system for the web, and we don't have enough time now. But what are some learnings from back then that this audience, people like me who are from a later generation, could learn from as we build the agentic web?
So the main thing that's interesting is that DNS and the internet has evolved over 4 decades and successfully did it from, a bunch of stuff hanging out on MIT and UCLA and BBN campuses to this, huge internet that's going on. Akamai alone is doing 150 million web transactions a second, 24 hours a day, 7 days a week. So it's a lot scale change. So the main thing is that, as you said, DNS has all these problems, but it also has solved a lot of problems over the course of the 40 years. And so adding to remember what we did and to use DNS as a starting point to say, hey guys, if you wanted to do this over again, what would here's our chance. What can we add to it? So we would like to add, when you do the resolution, you'd like to have some of the context of the context being like where the geolocations of the endpoints are. The fact that there are now more than one person who might want to talk. You might want to be talking on some sort of message bus where there's a lot of queues and you're playing a role. So how do you add all those extra features into the conversation between it? And we're not starting from ground zero. We got 40 years of experience, and so we can go on for that.
Yeah, I think one of the big things to remember is we're going to look to see what we can use today, and then we'll see what we need to build tomorrow, right? That's the whole point of this. Is it's going to be a hybrid approach. It's going to happen over time. We're not just going to instantly turn one off, turn the other on, right? It's not going to be that way. But one of the key things in one of our fellows at our company, I know she hates this name, but she's actually called one of her nicknames is the mother of the internet. And she does. She's won awards. She has everything to back it up. The big thing that she always talks about is the fact that back when we started the internet and started thinking these things through, they were told security is not an option. They didn't have the compute capabilities to handle encryption, to handle all of these other things that we do now. We have accelerators that can move all of these things, right? From routing protocols to all these things, we can now rethink them with a security mindset from the beginning. And I think, so the two things are, one, think security first. If you think you can't add something today, plan for it to be added tomorrow, because it's gonna change. And then allow us and join the journey of this hybrid approach to figure this out. I think those are kind of the lessons that I would want to bring forward.
Yeah, so I want to add another couple of points. So I do agree with John that, DNS really is amazing over the last 30 over something years. And pioneers, I mean, you obviously look like one of the pioneers, and Dan Kaminsky, and he was one of the pioneer in DNS security. Sadly, he passed away 2021. And so what I'm trying to say is, because at the time when we started DNS, we didn't know the issues we're gonna have. And then we spent many years, over the past, decades to patch it, building security solutions, DNS classification, content classification, and beef up DNS infrastructure. And now we learn from DNS security. We're going to address these issues from up front when we build NANDA. And so that's one thing I want to talk about. If you think about at the time when we did DNS security, and Cisco umbrella is pretty well known, and so we basically, scan the entire internet, billions of websites, and we do testing, and we do the sandbox testing. We classify the content into categories, and we call that one of these, security intelligence. So enterprise can actually create policy based on a DNS domain name and the classification, and create a policy to to control the access to certain domains in certain category. And we're going to be doing a similar thing eventually again in agentic world, right? Enterprise business need to have a security policy, not just for human users, but also for AI agents. And what kind of AI agents you can talk to over the internet, what kind of data you can share, what permission you can have, and everything need to be logged, authenticated. So it's the same set of problem, just expressed in a different way.
It's so true. I think, and we've touched upon this in many ways, which is that we have the chance right now to build for agents from scratch with all the experience that we have over the past 4 decades, and that really counts for something. I'm sure we can have this discussion for hours on end, but we're coming up on time. So, Rob, maybe if I can ask you one of the final questions, which is, what does success look like for the agentic web? So if we do everything right, we hope we have till now, and we hope we continue to. What does the agentic web look like in 2 or 5 years? And like, why is it so important to get this right?
So I was at one of our big customer events and big partner events. So there was thousands of customers and partners. We've struggled to get cloud right for the last 15 years. I'd argue we're probably close, but we probably still don't have how we should use cloud in utility compute and utility, services correct yet. I don't know if this can wait 15 years. I don't know if we could even wait 5 years. The velocity is moving so fast. It just has to be right. We have to come out of the gate closer to being right than being wrong, because I can see the benefits of this, and I want to live in that world, and I can see the downside of it, and I don't want to live in the world, right? I'm torn. I'm right on that line, and so I think that's one of the big things is it's either going to go really, really good or it's going to go really, really bad. I don't know if there's a middle, and we haven't had something like that, at least not in my lifetime. And I know, everyone says it, right? That, oh, in my lifetime, that this is the thing. I think we're living that thing. We're either going to get it right and it's going to be phenomenal. We're going to get it wrong and it's going to be horrible. I don't see a middle. So I can't tell you which way it's going to go yet. Hopefully next year or even in 6 months, maybe we'll have a better feeling, but that's all I got for you. I don't know if you gentlemen have a different perspective, but.
from the how perspective, I think of agents as being these, they have all these internal components that very easy to implement on web as components, and hence they can be deployed anywhere you want. The current, let's say, Kubernetes is all based on having it all be in one data center, but there's nothing that says that it's that an agent isn't like an amoeba, and that two amoebas come with their little long arms, and they come and they touch each other, and then they have communications between them. So the idea is, what's going to happen, sort of in economically? We got 5 billion of these smartphones on one side, and you have these huge data centers like I think it was Meta was trying to build 2 square miles of data center in Louisiana, soybean. So they're going to be building these things, and they're going to get all this equipment out there, and it's going to be obsolete after a year and a half. And how are they going to capitalize it? We have all these phones. So where's that play? Who's gonna own the center? And then some place like Akamai has like 4,000 sites where we have all these legacy hardware. So how is this all going to lay out across it? And depending on how that goes, whether it's easier to make data centers or easier to have Apple make a smarter phone, is going to play out. It's going to be really interesting.
Sichao, if you want.
I just want to use, potential examples just to provoke us to think about this. Eventually, for example, one day you, as an enterprise organization, you're going to be hiring a virtual agent, and the virtual agent maybe is provided by ServiceNow, and maybe provided by Salesforce, and is on a contract basis. And that virtual agent is like human employee, has to go onboard process, has to be given permissions to internal tools, have to be given permissions to access the internet, and they'll be given a task, and they'll be paid. And each of these steps, and it's going to be happening. But how are we going to make sure this is smooth, clean, and also secure, and takes all of us to work together?
Thank you so much, folks. Thanks so much, Sichao, Rob, and John. I think this last point is very critical because, as all three of you emphasized, this is the technology of our era. It can go one way or the other. And it is through forums like such where experts with experience, historical context, current knowledge, everything like this come together. And that's the goal of Project NANDA, to bring all such like-minded folks together and increase those odds very slightly that it goes the right way versus the wrong way. With that, thank you so much to all three of you. I think I'm sure everyone appreciated it a lot. And yeah.